Hi everyone, welcome to another video. This is Sam Gabriel. Thank you for joining me. In today's video, I want to talk about the Vault agent and address an issue with the restart of the Vault agent if it's running on a VM and how it loses its way of authenticating into the Vault server and how we can solve that. So we're gonna whiteboard the problem and the solution, and then we're going to see demos as well. So let's get started. Okay, so what you see on here on the screen, let's draw this out. Let's say we have a Vault server here, and this Vault server doesn't matter where it is. Could be running in a VM, could be running in a Kubernetes container, it could be in HCP Cloud, which is HashiCorp's new entrant into the cloud space with Vault as a managed service. So that is fine. We can use any of these Vault servers, but then we have a VM. So this VM, let's just draw it here in blue. This is my VM, and the application itself lives inside the VM. But there's also, in addition to the VM, there's also a Vault agent. We'll just draw it like this and put A in here for the Vault agent. And this Vault agent needs to talk to the Vault server. Let's use the red line here, right? So it needs to authenticate with the Vault server to be able to retrieve secrets on behalf of the application. Now, for this all to work, we need to have a file or a couple of files on the VM, inside the VM, that will host the wrapped secret ID. And I'll just abbreviate secret ID with SID. So you need a wrapped secret ID that will sit inside a file. You're going to also need the role ID as well. So this takes into account using app role. So here we're going to use app role to authenticate the Vault agent with the Vault server. Okay, so we have our VM, we have our application, we have the Vault agent, and the reason for all this really is that the application wants to talk to the Vault server through the Vault agent. This could be for a number of reasons. One of them is caching. You want to cache the secrets here. Obviously, you want to also deliver secrets. So what you can do is you can do two things. You can have the Vault agent drop the secrets somewhere in the file system here, and then the app can retrieve those secrets from here. But as well, you can talk to the Vault server straight through the Vault agent without talking externally to the Vault server. So that's all good. But the challenge is when, like I mentioned in the beginning, when this Vault agent restarts. So when this Vault agent restarts, the wrapped secret ID is now, you can only use it once, so you can't use it again. So let's just say here, used once. And this is by design. So the reason we're using a wrapped secret ID rather than the actual secret ID is for security reasons. But when you're using a wrapped secret ID, what happens is you use the wrapped secret ID once to unwrap and get the actual secret ID. But if you try to unwrap again, the operation fails. You can only do this once. And the reason being, if a hacker tries to get to that and tries to, for some reason, is able to talk to Vault and unwrap the secret ID, and then your actual application or the Vault agent is trying to do the same, it's going to get a status code 400 saying, no, this is invalid. We cannot do this. At that point, this needs to be audited, and you need to show and you need to investigate what happened, because you know if your application can't unwrap this, then somebody else unwrapped it before you. So that's where you got to investigate. And I have a separate video. We talked about that earlier. I'm going to link that into the description of this video. But now we kind of understand what the problem is. Here, this is going to fail. So the agent is not going to be able to come back up. If for some reason the entire VM, restarts, or the Vault agent itself restarts, now you have an issue. And I didn't mention, but the way this wrapped secret ID came to be here in the first place usually is using a trusted orchestrator, such as a Jenkins, for example, within a pipeline. So Jenkins is going to come through the pipeline, talk to the VM, drop the wrapped secret ID, maybe drop the role ID as well. And one solution to this problem is to rerun the Jenkins pipeline. But then you have to worry about, okay, well, what happens how do I know when the VM has restarted or the agent has restarted to trigger another Jenkins pipeline run? So it's not a very straightforward solution to this issue. So let's do this now. Let's jump into my CLI here, show you what happens in a demo fashion, and then show you the solution in a demo fashion, and then I'll go back and walk you through how the solution actually works. All right, so here I'm in my environment, and I have in the file system here, I have a bunch of files. This is all in the GitHub repo that I will share with you in the description of the video. But basically, to get this to work, we first run this start script. And what the start script is doing, it's actually doing a few things. One of them is an admin, a Vault admin, is going in to create an app role path. So it's enabling actually the app role authentication method. And it's writing a couple of policies. And it's creating the roles, the app role. And it's actually depositing a key value secret and dropping the wrapped secret ID and the role ID in here inside of this VM. So now if I go ahead and start my Vault agent, as you can see, it starts up fine. You can see here authenticating, starting the sync server, authentication successful. So it was able to successfully authenticate with the Vault server, starting the renewal process, token written. Now it has the Vault token that you can use, the application can use to talk to Vault, renewed the auth token. One thing to note here is it has a listener. So you can, and I mentioned that in the previous video, you can point your application to this local IP here on port 8007 where the Vault agent listener is listening, and this will kind of proxy your connection into the Vault server, and it will cache your leased secrets and tokens. Okay, so now let's do this. Well, let's stop the agent and let's try running it again. Guess what? It's failing. And that's exactly what we're trying to solve for. And you can see the error message right here, right? Error getting path or data from method, error looking up wrapped secret ID, status code 400. So basically what we're saying is that we're not authenticating, we can't authenticate. The agent cannot authenticate with the Vault server. Why? Because the wrapped secret ID has been unwrapped before, so it's useless at this point. We have to somehow recreate that wrapped secret ID and put it in that location where the Vault agent can pick it up. All right, so let's stop this and let's look at the solution. So in this case, our solution will be, I'm gonna once again drop the script which simulates a Vault admin, once again creating the app role, creating the policies and the role, dropping in a secret. But it's also, like I mentioned before, dropping in a a wrapped secret ID to get us started, but it's also dropping in another secret ID that we're going to talk about. We call it the restart secret ID with another restart role ID. All right. Now let's start the agent. And if you notice, I'm using systemd to start the agent at this point, and you'll see why in a second. Now let's take a look at the status of this process. So here's the status of the agent. Once again, it's ready to go. It's good to go. It's authenticated. Everything is fine. Now let's restart the agent and see what happens. So let's run system CTL restart. And let's once again take a look at the status. And you can see that we're still running. Everything is fine. And that's the point. At this point, this VM restarts, the process restarts. It doesn't matter. The agent will come back up and be able to service your application's needs, and you're good to go. So we've solved that issue with restarting the agent. All right, well, let's go back to the whiteboard and figure out what happened. How did we come to this solution? So let's get back here and let's take a look at the actual solution real quick. So these are the steps for the solution. I'll go through them quickly and then I'll touch a little bit on the configuration itself. But before we get there, maybe a drawing would help us. So let's take a look at the same drawing that we had before. Here's the VM where the application lives. You can see the app right here. Here is my Vault server. And here's the Vault agent, and it's managed by systemd. We have the wrapped secret ID file, once again, that the Vault agent is going to use to start up. And then we have a restart role ID file and a restart secret ID file that's new. And these two files are going to be used, and this is key, into having an additional app role that has a very limited policy scope to begin with, that this will already be available inside the VM. So as you start the VM through a Jenkins pipeline, it will drop these role ID and secret ID files with an attached policy to bootstrap the agent. And in the bootstrap process, there's a script that's going to run and grab or create a wrapped secret ID for us, drop it in the proper file location, so that the agent, every time it restarts, grabs a new wrapped secret ID for us. So that's in a nutshell what we do, or the solution. To get into more details, the high-level steps are here. So you can see there's the Vault admin. He creates a tightly scoped policy that only allows creating a wrapped secret ID and nothing else. What does this policy look like? If we go up here, you can see it's a very simple policy that gives the capability to create, read, update with a minimum wrapping TTL and maximum wrapping TTL. That's all that role ID or app role can do. It can't do anything else on Vault except write or create a new wrapped secret ID. So that's key, because from a security point of view, you obviously want to be careful of what you're allowing to have on that VM in terms of access into Vault. So that's the first piece. The second step is for the Vault admin to do the following. Create two app roles, one regular one for the Vault agent and another one for the Vault agent restarts, as we saw before, the role ID and the wrapped secret ID. A Jenkins pipeline or a user delivers one role ID and one wrapped secret ID to the app VM, in addition to one restart role ID and one restart secret ID to the app VM. The restart secret ID never expires and will be used to authenticate into Vault when the Vault agent restarts to create a new wrapped secret ID for Vault agent to unwrap and start successfully. Okay, so we touched on that. Let's take a look at the actual config. Step number 2 here, we're creating this by a server admin. So this is created only once. You create an app role, you create a policy, well, two policies, in fact, one for the Vault agent and one for the Vault agent restarts. And again, this is a tightly restricted policy tied to this, that will be tied to this app role. Now we're creating two app roles. The first one is the Vault agent app role. You can see some of the limitations we're putting in here. So the secret ID TTL is 2 hours, for example. These are all suggestions. You can tweak them as you wish. But it's tied in with this particular agent policy that we defined up here. The second app role allows unlimited number of secret ID uses. This is very important. And it's tied to the policy that we defined earlier, the restart agent policy. And that is defined over here. After that, we're reading the role ID and we're putting that into the weblog role ID file. We're also creating a wrapped secret ID and we're depositing in this weblog wrapped secret ID file. And then at the end here, we're reading and writing the restart role ID and the restart secret ID. All of those are being dropped in the respectful files that we talked about before. In the respected files. Okay, number 3, Vault agent config doesn't change at this point. We have the exact same configuration that we saw before. And here's what the configuration looks like. So we need to put the address of the Vault cluster, the Vault server itself. We also need to define the auto auth stanza here. As you can see, the method that we're using is app role. This is key to note here, these 4 commands in the config file. The role ID file path, the secret ID file path, remove secret ID file after reading. Whether you choose to do that or not, it doesn't really make a whole lot of difference, because once the wrapped secret ID is read, that's it. You can't really do much with it after the fact. And the reason this is here is because you could actually use the secret ID file directly rather than the wrapped secret ID. In this case, when you put this command in place, secret ID response wrapping path, we're telling the Vault agent that the secret ID or the wrapped secret ID at this location is actually a wrapped secret ID, not the real secret ID. That's what this line is doing. We're using the namespace admin, so we're using the extra. What I didn't mention is that the Vault server that I'm using is actually in HCP, in HashiCorp Cloud Platform. So that is an enterprise one. It doesn't really need to be an enterprise Vault for this all to work. But in this case it is, and we're using the regular admin namespace. The sync file is where you're going to have the Vault token live, and then the listener, we're listening on port 8007 on localhost, and caching, we're allowing caching for this config. So that's it with the configuration. Step 4, add Vault agent systemd service on the app VM. Okay. Now this is important. We need some supervisor or some method to take care of the agent service itself. And I'm using systemd in this case. And as you can see in systemd, we are running this restart agent script as systemd comes up, so or brings up this service. And this is key. This is where we're going to do all the things I talked about before. We'll see that in just a second. Step 5, start the Vault agent with systemd. You need to copy your Vault agent service file, which is this file, into this location, and then run the service as I showed you before. You enable it, you restart it, and you're good to go. Now, if the Vault agent restarts, step 6, what happens? Vault agent starts with a bootstrap script managed by systemd. It effectively authenticates to Vault with the restart role ID and restart secret ID that don't change. The script then creates a new wrapped secret ID and drops it in the same folder where the Vault agent expects it. And this is the final piece of configuration, and this is really where the Vault agent starts off, it's a bootstrap script, if you will. So once again, we're identifying the address of the Vault server, the namespace we're operating within. We're grabbing the restart app role credentials from files. So we're just reading the restart role ID. We're reading the restart secret ID so we can log into Vault. Authenticate to Vault with the restart app role creds. Okay, so here we're going to use this Vault token to authenticate. Echo restart token just to show you what the Vault token looks like. And here, writing a wrap secret ID to the same file that the agent expects from its config. So this is the key step where we're dropping the wrapped secret ID that we just generated into this location. And once that's all done, now we can start the Vault agent. And you can see the command here to start the Vault agent once we have everything in place and ready to go. Now, hopefully this has been helpful. This is all inspired by this article here on the Learn HashiCorp site, recommended pattern for Vault app role use. And if you go here and read, you'll see that this is basically what I'm trying to do, but instead of using a Jenkins CI/CD pipeline, in this case, I'm relying on systemd and a script to get this all running. So it's inspired by this article, by the different steps. There's a little twist to it, of course, for our use case, but it's kind of the same way. It's a recommended pattern for app role use. So hopefully this has been helpful to solve the issue that we talked about earlier in terms of restarting the Vault agent inside of a VM. This issue really isn't that big of a deal when you're running inside of a platform like Kubernetes or even one of the cloud platforms, where the Vault agent itself can get its identity from that platform and use that as opposed to an app role to authenticate with Vault. And that's really the issue that we're running into here. However, in many customer environments, we do have VMs and we have to deal with that. And this is the solution to do that. Thank you for watching.